Welcome back to our session on information-theoretic estimators for continuous value data and JIDT. In this short video, we're going to pick up where we left off in the last video, where we had made our first calculation using the AutoAnalyzer GUI with the Gaussian model estimator on continuous value data. Here, we're going to look at the code that was generated and talk about the usage paradigm for these estimators, in particular in comparison to the discrete estimator that we already looked at in a previous session. So in the first place, we've made our calculation here, and we can see we've got the code in Java, in Python, and in MATLAB. And indeed, the code for each of these is generated in Demo's AutoAnalyzer, as we saw for the discrete valued estimator. And we can run these very quickly just to verify that. So I'll run the MATLAB Octave code in Octave to do that nice and quickly. We get 0.37 nats again. We can run the Python code out here in Python 3. We get the same result again. So just verifying we get the same result from that generated code in all of the different languages. Okay, so you can have a look at the code either in the tabs here or in the files that I just pointed you to. The first thing I want us to think about is what looks different here. What looks different to the discrete code that we looked at before? So take a moment and have a think. In whichever language is your chosen language, what looks different here? I'm going to look at it in Java. And the first thing that pops out is the data is different. For continuous value data, we're now dealing with arrays of doubles rather than integers. And of course, we'll handle those differently in Python and in MATLAB as well when we convert those values to native Python and MATLAB arrays. That's one difference. Another difference is we've now got set property calls for our estimators as well. Let's talk about both of these in a bit more detail. Okay. So we've already talked about how the data is different. We're now talking about doubles. The usage paradigm is different for continuous value data compared to discrete data as well. So you'll see now we have a new step here, number 2, calling set properties on our estimator to set different properties of the estimator type. We didn't have that for the discrete valued plugin estimator. We've also got another choice on how to supply our samples down here. Previously for discrete value data, we just called add observations multiple times. For our continuous estimators, we can either call set observations just once, or we can call start add observations, call add observations multiple times, and then call finalize. The choice is yours depending on what kind of data you've got. In the future, we plan to streamline this flowchart to pull it in line with the flowchart for the discrete value data, but we're not there yet, so we've got this split here. Let's now go through the different steps in the code. In particular, we'll look at how those steps are different for the continuous estimators compared to the discrete. So here I've just pulled out some code from the AutoAnalyzer, and I've stripped out some of the comments so we've got something simple to look at on the slides. We're just going to look at the Java code in particular here. If you want to go through the MATLAB or the Python code, you can do that in what's been spat out by the GUI tool as well, and most of the calls are almost the same. We'll start with the constructor. Your first step is, of course, to construct yourself an instance of the calculator, remembering that we're using object-oriented coding, so our calculator is an object here. So we need to construct ourselves an instance of the calculator, and when we do, we possibly provide some parameters for that. You can check the Java docs for full details on which parameters can be provided in the constructor. Most of the time though, and in particular the way the GUI tool will work, the parameters can always be provided later to allow a dynamic instantiation, and we'll provide those parameters with our set properties calls that we'll talk about on the next slide. In any case, where there are parameters, the AutoAnalyzer will take care of those for you. Just put them in to the properties table, and it will show you how to do that in the code. Again, the constructor syntax is different if you're programming in MATLAB or Python, and have a look at the generated code to see that. Let's have a quick look here. So in Java, we see that we create a new instance of the class in this fashion. In Python, we use the J package call to tell it which class to create an instance of, and in MATLAB, we use the Java object call. Again, you can go through the code there at your leisure to see how to do that, or just rely on the GUI tool to show you how to do that itself. Okay, next, step 2 is to set properties on the calculator. This is something that we didn't see for the discrete valued estimators. It is something that all the continuous valued estimators have. They're generally more complicated, and so we have the set property call to allow you to set all the different parameters that they may have, or options that you may want to take. So in the Auto Analyzer GUI, you can hover on each parameter to read about the options that you have. And we've seen this before for the discrete valued estimators. Again, here, if we hover, we see the description for the time difference property. The different calculator types will have different properties. We're looking here at the Gaussian model estimator, which is very simple. Others have more complex property sets. In any case, when you set them to a non-default value, you will get steps generated here at step 2, different set property calls for each one. Okay, let's have a look at what we say about that in the slide. So here we see the example, we set the time difference to a value of 1. The set property calls are always made using key value pairs of string objects. Okay, so even though 1 is an integer, we supply it as a string here. Again, the Auto Analyzer is going to take care of that for you. The properties that we set are only guaranteed to hold after the next initialize call. So that's why you see it in the flowchart and in the code being done before initialize. Okay, so make sure you set those properties before you call initialize. The properties can also be easily extracted and set from a file. You can set all the properties you want in a file and basically throw the file in. You can see how to do that using our simple Java demo number 6. I'm not going to go through that here. You'll also find that there's a get property method as well. If you want to read out the properties later on, you can call get property with the same property name and extract those values. Okay, next up, we initialize the calculator exactly the same way as we did for the discrete value calculators before we use it or reuse it. And in particular, this will finalize any new property settings. It also clears the PDFs in case we're reusing the calculator for some new samples. For the continuous valued estimators, sometimes you are able to supply some parameters in the initialize calls. The way we use it from the GUI tool, it doesn't do that. You have the option. If you want to look into that, you can check the Java docs, but I'm not really going to go into that here. That's an optional way of doing things. Then we supply the calculator to construct the probability density functions. We can do this with one call to set observations, and that's what you'll always see from the GUI tool at the moment. But if you've got multiple sets of observations, for example, from multiple trial runs, then what you're going to do is call add observations multiple times in between start and finalize add observation calls. Importantly here, when we send the data in, we need to convert the arrays into a Java native format if we're coming from MATLAB or Python. So in MATLAB, we're going to do this using Octave to Java double array or double matrix calls, and that's a method I've supplied in the demo/Octave folder. And from Python, we're going to use the JArray conversions, or for continuous valued arrays, we can pass NumPy arrays in directly. We couldn't do that with integer with the discrete value calculator. And you can see the difference if you go back and look at that lecture. Let's have a quick look at the generated code there. So we can see in Python, we've written our data to a NumPy array here, and we've pulled out columns there, and we can see they can be passed straight through without any extra conversion here because they're in NumPy array format already. As I say, that's not the case for discrete value calculator. To see the difference, go back and check that previous session. For MATLAB, we pass the data through this Octave to Java double array. Strictly speaking, if we're running this code in MATLAB, we don't need to do this. It will do the conversion for us. In Octave, we do need to do this. So to be safe, just pass it through this function as the GUI shows you, and it will handle it behind the scenes for you, whether you're in Octave or MATLAB. Okay, so just go with how the GUI does it for you. So finally, we make a computation in exactly the same way as we did for the discrete valued calculator. Now here the values may be in bits for the kernel estimator or nats for the KSG or Gaussian estimators. You can always tell which one it is if you forget, because the print line at the end, I tell you whether it's in nats or bits. If we switch to the kernel estimator, that will tell you it's in bits there. Okay, so if you forget, that's where you got to look. Just look at the print line from the output in the GUI tool. Okay, same as with the discrete calculator, we can compute other things here. We can compute the local or point-wise values, or compute the statistical significance, which we'll discuss later on. So just to summarize, the usage paradigm here for continuous estimators is as follows. It's very similar to what we already saw for the discrete calculator in the previous session. We've just got the difference here that we've added our set properties method that can be called multiple times, once for each property, and we've got our two different options of setting the observations once or adding observations in multiple times if we follow this calling pattern here. In the next couple of short videos, we're going to look at some of the other continuous estimators, the box kernel estimator and the KSG estimator, which will use this paradigm as well.